Hi, welcome to the third part of this refactoring of our identification model. So, last video we were talking about how to get rid of the identification related types in the logical model, which we did, and then we had to deal with the fallout in terms of compilation errors, which were quite a few. So after that video I continued. I think we need one more area here. Compilation. It's a shame we can't really see both monitors. So let's make sure we're recording, and we are recording. So what we did is, after that video, I went through a lot of errors and made a few commits, as you can probably see here. The usual temps. I mean, one thing I would say, I didn't mention this in the previous video, but if you're doing this in the real world, really, you should really create a feature branch and push that to Git. Even though these are temporary commits, you should probably just commit them and try to actually describe. I mean, I'm being a bit lazy here, but good practice should really be that you describe the commits properly, you put them in the feature branch, you push them over to GitHub, because of course if something happens to the PC, then you're going to lose all that work. So this thing of doing local commits and not pushing them is not a good idea. But you know, do as I say, not as I do, and all that. So what have we done then? We went over to so you fixed all the compilation errors, as I was saying, and now we're down to test errors. So this is slightly more interesting than the random compilation errors we were having before, so I thought might as well record fixing some of these, or maybe all of this if we're lucky. Let's see how much we get done in a couple of hours. So tests we are failing at the moment, as expected, are just code generation tests. And the error we're getting at the moment is expected archetypes for module. So what we'll do is, and as we tend to do for this kind of problems, is excuse me, we are going to enable logging and just generate this very simple model, because most of the time logging gives us enough clues, I guess, as to what's going on. So I mean, we could of course enable logging for the tests, but it's just slightly more painful than actually just running a code generation. Actually, do you know what? I'm just gonna change these two areas, because I normally have compilation on area 5 and RG on area 6. And then my keys, I get used to the key bindings, and then so this is easy now. Okay, so let's just try to do something like generate Dogen.diet, a simple model. We have a different error from the tests. Let's look at the error again on the tests. Okay, so in this case we're getting a very different error from what we're getting from the code generator. I wonder if it's because I didn't build the code generator for a while. Oh, okay, good. So now we're getting exactly the same error, so that means we can debug this. So if we go up to area 4, our logs, and make sure you get the right model, generate Dogen.diet, that's this guy here. Okay, so first thing to do here is try to understand where we are. And we're in this transform, which is this guy here. And the log is telling us that there are no physical metanames. Okay, doc. So there we are. Let's try to understand the context of this error. So we're trying to do some kind of population. We're receiving logical elements. Seem to be tracking the IDs, so that's fine. Oh yeah, we're building the text model at the moment. So create the artifact set which represents, I don't want to use the word manifold anymore, a region in physical space. Or maybe we should say the region in physical space. For this logical position, we start by populating the Max is slowing down on me a little bit. Something to do with 3max. Let's just refresh 3max. So we're just basically creating this region of space in logical physical space that contains both the logical elements and the physical elements. So we start by obtaining a meta ID. This could be replaced by an auto, and then we create the provenance for the element. And we obtain its configuration. We're going to take away all the references to manifolds. As I said, manifolds, mathematically speaking, is not a very good term for this. We mainly create about sets that have potential to be generatable, although we keep all of them, even the non-generatable ones. Note that this is only a hint from a logical perspective, though, and does not simply not imply that these will actually be generated. Actually be any generation. This is dependent on physical configuration and enable. Okay, cool. Makes perfect sense. Trying to figure out what's going on with generability. Right, now then. Obtain all of the archetypes associated with this element's metatype, if any. So, according to this, the problem is we're trying to obtain the physical metanames for the module. So now it's all making a bit more sense. So if I go back to the log file on 4, we're just about to process module. We have a module in the logical space and we're trying to say, okay, what meta archetypes, or what archetypes, meta artifacts, what archetypes exists that can transform a module, and then quite nicely, and this is why we have so many checks in Dogen. We basically say there is no archetypes for a module, but then somebody is then saying, oh, wait up, I expected to see some archetypes. And that's quite nice actually, because the generability status here checks the expectation of archetypes existing. And because none were found, it then bombs out, which is really nice, because if you continued, it would have been tricky to figure out what's gone wrong. So we know that there should have been archetypes and there's none. So this means that there's some kind of logical error in the code. So that was actually quite a useful check to make, because it's now saving us a lot of time. Now what we need to do is try to understand why it is that there are none. So archetypes, so we go back to the index names. Archetype names by logical meta name, and that's returning nothing, and then we know that comes from the index names in the physical meta model. And all we need to know then is how is physical meta model. Let's go back to physical meta model here. Here's the guy. It's got a set of index names which come from the identification. Presumably there will be some constructor, some factory, the meta index name builder, responsible for creating this guy here. Okay, cool. So now then, we just need to make sure archetype names by logical meta name, there it is, logical meta ID, archetype name set, that looks nice. We just need to have a look at what the meta name index builder is doing. That will tell us everything we need to know. And that chap hopefully will be writing something to the log file. There he is. So now this is another thing, I think another tip I guess that I'd say that I've learned over the years is log files are really important. I mean, of course, I'm not denying that you could use a debugger, and debuggers are really useful and so on. But it is nice to be able to just go to a log file and have all the information there. For example, it tells you when you're doing something silly you don't realize. Look at this log. It's actually not telling us a lot of useful things, because So it's telling us it's adding a list of physical metanames. It doesn't tell us what these metanames are. It tells us that the names are valid, and it tells us we added them. So this is not very useful. So we need to go and fix this log. What we'll keep doing is we'll keep going until we get to the end of it, and then let's look at the index to see what we think this container has. Then again, we have our usual niceness of JQ, so I can easily say in JSON mode. Right, so these are the indices, and we can quickly look at archetype names by logical meta name. Let's have a look at what these keys look like. So we have a few here, but notice very importantly, some of these are blank. Blank is not good. Really not good. So someone is populating this with a blank value. So the first thing we need to do is to make sure that we validate these logical metanames to ensure we don't end up with a blank meta ID. So these are archetype names by logical meta name. Let's just have a look at the type. Actually, probably can get away with looking at the model itself. Archetype names by logical meta name. So that's a logical meta ID and then an archetype name set. This chap here. So you would have thought that logical meta name, yeah, correct, and then the archetype name set. So why does the archetype name set require a logical meta ID? It's peculiar, isn't it? It should have been populated. So it seems to be slight problem with how we're populating this. But that's not too bad actually. We can fix that. That's easy. What we need to understand is, does it look as if we're populating all of these logical meta IDs? So if I look for something like let's just do something really simple. Let's just say JQ interactively, and so dot let's have a look. Dot this guy here, and then it's an array, so presumably you go into the array. And then something's not quite right without JQ for some reason. Let's just get out of it. Let's just use plain JQ because I think JQ and Emacs is getting a bit confused. So if I just do that, okay, that's good. And then if I then say, please give me on this array the elements, flatten it. No luck. Yeah, it's interesting. I don't know why I can't flatten the array. So JQ dot array. Okay, here we go. Flattening. And now we should just have the top level array. It's good. And then I wonder if I can just then say for each array, give me the first position of that array. There we are. And perhaps we want the 0th position actually. There we are. Okay, so now we got all the keys. And then for all the keys, we would like to see their data, not value, I believe. And as you can see here, quite nicely, we have an entry for Dogen logical entities module, right? So to recap what we just did here, we did a quick check. I mean, another way of doing this, of course, I think you may now tell me that I just went a bit overboard with JQ. I just love JQ and use it for everything. So if I just go back to the beginning, another very simple way of doing this would have been just JQ, look for that entry, and lo and behold, there it is. But it also shows us that all the keys look more or less sensible. The main problem is we don't seem to be populating the logical meta ID inside of the container. Key thing is there is such a thing as an entry, and that entry contains, as you'd expect, at least one meta name, which is the namespace header. So that looks very good. Now we know that our container seems to be populated correctly. What we also know is somehow, by the time we try to do a lookup in that container, which happens around here. Okay, we went to the factory, didn't we? So let's just ignore that for a second and go back to the transform. So when we finally look at that container and we do a lookup for the meta name, we don't seem to find it. And I think the problem is that the meta name is not qualified. If you look back at the log file, it says module. But if you look at our container, as you've seen in the container, it says this guy here. A completely, fully qualified name. Now, that is very peculiar. Why would some people be talking about fully qualified names and others not? Now, the reason why this is somewhat unexpected is because if I look at the meta name factory, we are not using qualified names anymore. You can see here, these are not qualified names. So it seems to me that we seem to have put the code out of sync somehow. Someone is qualifying names and some other people are not. This is exactly the kind of thing you'd expect when you do a massive refactor like this. You do some assumption somewhere, you forget all about the assumption, and then it all goes very wrong. So what we'll do is, for a laugh, we'll just do a quick grep. And as you can see here, the logical meta ID that's being supplied through via the template is a fully qualified meta ID. Now, there are two ways of fixing this really. The first one is we can just hack the factory to have the exact same qualification. Because as you can see, the reason why we remove the qualifications is this qualification is not even right. What it says here is Dogen logical entities. But if you were to actually look at the logical model and look for module, you'd see it's inside of structural. There it is. So really, if you want a qualified logical name of this thing, it should really have been dogen.logical.entities.structural.module. So I then decided, well, since this is just all made up anyway, let's just not use a qualified name. However, what I did not do is I did not update the templates to do the same thing. Because of that, we now have an inconsistency. Okay, that's fine. So let's just do something really simple, and let's just see what the templates are saying. So if I take something like, I mean, we've done this before. I think I had to restart Emacs, that's why it's forgotten about my modes. So what we need to do is to just go to stitch mode. We have a couple Lisp files in our projects. Polystitch, there it is. If I just, I should really set up Emacs to automatically do this, I know, but as with everything in Dogen, just not enough hours in the day. If I just say templates in my area here, and stitch mode, and as usual, I need to disable LSB mode. I have to do it twice, funnily enough, because no, actually just once probably would have been enough. And then here we just use mustache, and there we are. So the templates are enabled. Now what we need to do is we need to understand where in the factories where the logical name is being populated. So as you can see here, the logical meta element ID is being used to populate it. And this is populated and some kind of transform, I think. So if I go back to the logical transforms, somewhere around here, I should really use Emacs bookmarks. So if I look here for physical entities transform, and if I look for the logical meta element ID, as you can see, is here. Now, how exactly is that being populated? So we seem, right, bingo. What we seem to be doing at the moment is we seem to say that the logical meta element ID is a configuration element, which then means that if I look into this guy here, no, I can't see anything in the configuration. So where is this coming from? One wonders. So first we get the logical model meta element ID. It must be empty. It must not be empty, otherwise we don't validate it here. This will be done later on. So the question then is, yes, I understand now. We have to look at the templates themselves, and each template, yes, it's making sense now. So if I look at each template now, say for example, let's look at the namespace. This guy here will have a logical meta model element ID. There you are. Right, so what's happening at the moment is that every single one of these guys is pointing to a fully qualified meta model element ID. And that fully qualified meta model element ID is no longer lining up with the factory, because we hacked the factory, removing the qualification of the meta model element ID. What we're going to do is we're going to quickly hack this. The reason why, let me just explain to you why the hack is sensible here. The truth is, the meta model element ID, which we've been using as some kind of like pseudo namespace location of the meta model element, that is not really what we should be using as the meta model element ID. The meta model element ID should be the stereotype. The reason why it should be the stereotype is because the stereotype is the thing that actually identifies the meta model element according to UML profiles, and that's the thing that we should use throughout. And that is the right identifier. So what we need to do is we need to change all of the internal representations of the meta model element ID to use a stereotype. I'm pretty sure there's a story for that already. So what we just need to do right now is just to get this thing to work, so that in the future we can then go and fix this properly. So it doesn't really matter what we do. So we can just do something like space constant string prefix, and then we just leave some commentary, something like prefix for the meta names must match the artifact configuration. This is going to be replaced by stereotypes. Okay, so we now know why we have this prefix here and where we have to look, and so therefore all we need to do is to make sure we do prefix plus the simple name to create the logical model ID, and now with a bit of luck, when we run our tests, we should error somewhere else. And that just gives you a good feel for the kind of sort of investigation, the way we investigate things around here. As you can see, that fixed the underlying problem and moved us over to the diffs. So that's good, that's a good fix. Next problem then. Very interesting. Next problem is we are making use of the primitives extractor, and the primitives extractor is contains the entirety of the primitive, as you can imagine. However, for the purposes of this exercise, we don't really want the entirety of the primitive. We just literally want this guy here, which, as you can imagine, lines up to what we just said a second ago. So therefore, we need to somehow change all of the templates to do a value of the ID. That again is easily done if we go straight into the model. So let's just ignore the UI, otherwise you're never going to get out of here. Let's just create an area here in Emacs. So if I just go to the model, and it's going to be both the C# and the C++ model, they're going to have a problem. So if I just do a search, oh, interesting enough, it seems like we only do this in one place. Well, that being the case, I assume this is going to be the factory, presumably. So let's just have a look at the template in the factory. If it's just one, I prefer doing it via the UI. And you may think I'm doing this fairly arbitrarily whenever I use the UI and whenever I edit the XML. The reason why I don't like editing the XML is because every so often we forget about what we just did, and then we save something from the UI, and then one clashes with the other, and a lot of the times the errors that you end up with are really difficult. You forget about why it is that you're having that problem, and then it all goes very wrong. So now, no, that's a slight problem here. We need to first generate our models, and now I think we're going to have a problem. Let's see if this code generator is good enough to generate. It is, it seems, but now very carefully you must look at the diffs, because we may have just generated a whole lot of rubbish. Right, we should have done a temporary commit here, because now we don't know what's what. See, as you can see, this code generator is generating rubbish. Right, so this is a very bad idea. You should have always before you code generate, this is something that you should keep in mind. Before you code generate, you must make sure your diffs are clean, because if you don't, you will end up with a mix of changes due to generated code and changes due to something else. Look, you see here, we just broke something. Right, let's just try to clean up this mess. Clearly we have a dodgy code generator. I think everything else is due to the dodgy code generator. So there's only going to be one useful change here, and that's going to be somewhere in the factory. So if I look for archetype, around archetype, right, bingo, this is the guy. Now we have to be very careful not to take the bad changes with the good. That's the good. Everything else is rubbish, so we'll just do a temp commit here. I think safe to just stash this crook stuff, and then let's just create the code generator with just this one change. It does require quite a fair bit of fiddling with the generated codes. Make sure you've got the right thing. It's not ideal, of course. Just to double check what we just did. Sometimes you're going a bit too quickly, not paying attention. We should have obtained the value, and then we did the value. Oh no, not that. Where are we? Dot value. Okay, so hopefully that would unpack the primitive. Which also means you probably don't need any I/O. Now, interestingly enough, we saw headers changing. As I say, I think that is probably to do with the fact that we probably made a change in the diagram, in the XML level, and then that change got undone, I'm pretty sure, because I'm pretty sure we fixed that a second ago, those header files. So let's attempt to generate. Still have logging enabled, I believe. Maybe not. Let's see the fallout of this. So the key thing seems to be that we are referring to the old name factory. I think this is just this is exactly the danger that I mentioned a second ago. You start mixing and matching changes in the XML level with changes in the UI, and then at some point something gets reverted and you don't even notice how that reversion occurred. So you see here, this is exactly what just happened here. We must have somehow updated this with the old version of the model. So what we're going to do is, to a good measure, close everything down, and let's get rid of all of these guys here, because this method in factory does not exist anymore. So let's just say we don't want you. We would like identification logical method in factory. Now we save this guy, and then if we just go back to the diff, what we really want from this diff is, well, I think it's probably safe enough to just regenerate again. Okay, and then just see what we get. Okay, seems like we only have one change. Now, I would have thought we'd have more than that one change. I would have thought that we'd have all these values coming through. Let's have a look. Oh, it is value there. I wonder if... Let's just regenerate. This is one thing that sadly you probably have figured out by now, is the complexity of this is actually quite high, because you're generating a code generator that generates generators. And so you have to make sure that you're always working off of latest. And that's a very difficult thing to say, because if you think about it in terms of stages, is in the first stage you generate the code generator. But then you must remember to regenerate the code generator after you generated the code generator. What I mean by this is, you could make a change to the code generator, and that change then has to be built into the binary, and then you have to regenerate the code generator with that change, so that the code generator then generates the right code. So a lot of times you have to remember where you are in this process of generation, because otherwise you generate things in the wrong version of the code generator, which then results in incorrect results. Now, at this point in time, I'm slightly confused. I think we have the right change in the code generator, which is the dot value as you'd expect, but that doesn't seem to be coming through. So no, that's correct actually, because now if I were to look at that template that we saw a second ago, in fact the proof will be in the pudding of running the tests, because in theory we should now not be generating that strange logical element ID. And that's correct, we are not longer doing that, so that's good. Now then, what else are we doing that looks a bit strange? We seem to have removed string, or added string. Okay, cool. Now, presumably this is going to now be issues with JSON. So at this point in time, we need to update a few models. Let's start with convert Dogen.logical.dia. It's definitely not up to date. Over to JSON, of course. And then if we indent, sorry, we can only indent JSON. That didn't seem to have worked. Indent. Okay, and now let's have a quick look at the diff. I expect this to be a good diff, which it is. And then I think, well, let's just run the test, but I suspect we have a few of these breaks. Text model, for instance, sounds like one that probably changed. So if we look at the model name, okay, interesting. That's broken altogether. Not sure why, but I think we've done something very bad. So okay, that's fine. And now, so that's definitely product JSON model. That's fine. And this guy here, not obvious what model that is. Seems to be also the product JSON. Okay, not quite sure what that means, but nonetheless, let's just do that. It's whatever it is, it's in the product model. So we'll just indent it. I suspect what we're going to find is that somewhere in the product model we're doing a streaming of an ID, sorry, which then results in some incorrect invalid JSON. That looks perfectly fine. Let's look at this diff more carefully. In fact, the best thing to do might be to just ensure that it looks vaguely sensible as JSON. It looks like normal JSON. Confusing. Let's try running those tests again. Sometimes you're in the loop because you're looking for something and you're not actually reading properly the messages and so on. You're expecting the error to be somewhere instead of actually looking what the code generator is telling you. Right, we know for sure there's some dodgy JSON here, as you can see here. And we know the test that's failing is this guy here. So let's just start by that. So let's just look at RG and let's just locate this chap here. There it is. And that is loading, I mean, exactly what you'd expect. The Dogen product cpp.json, I'm pretty sure. Well, let's just not assume anything. Let's just have a quick look at what this chap thinks it is. Okay, it's the text, sorry. Right, fine. Product model is not what I thought it was. Not quite sure it's the name of this model. Not the best of names. So really what we should have done is convert dogen.text.cpp.diet over to JSON. And we should have indented it if I could spell. And again, valuable lesson here is the lesson we learn every time is never assume anything. Just check with your own eyes what the code says and make sure it's really what you think it is, because otherwise you may end up in a wild goose chase. So that's good. Okay, so we now know that there was a problem with the product model. I don't know why it was invalid JSON, to be fair, but sometimes it's just not. I mean, you have to pick your battles. So first thing is, what happens when you convert and look in the field? It actually resolves the JSON problem. So best not waste any time on that. Now then, Dogen product JSON. Again, I'm not going to do any assumptions here. I don't know why it shows these names at the time. These are not the best of names because I can't actually find the models from these names, so clearly they can't be the best of names. But there you are. That's what happens with the code base, and evolves over time. Let's have a look at what this model is. Oh, it seems to be on swiper. Be careful here. So if I just look for the Dogen product JSON, So dogen.text.json, so this is just the main text model. Again, let's just do the same thing. Convert it and indent it. And hopefully we shall see, as usual, there's spurious diff, and there's a difference that shouldn't have been there. Now if we just try to run the test for this, this is one of the difficulties really of supporting multiple input formats. We thought in the beginning that having multiple input formats was really important. There we are, everything is green. So just to recap, we support DI and we support JSON, and in the future we're going to move to an org-based format. I thought that we're going to have lots and lots of injectors, and the future of Dogen was lots and lots of basically what we now call codecs. In reality, the usefulness of this codex is very limited. It was important to have more than one because it allowed us not to hard code things. We could have just hard coded a whole lot of things if we just had one dia, for example. Because we had more than one, what it enabled us to do was it enabled us to do a lot of thinking as to what really belonged where. And I'll show you what I mean by that. Let's just go up to injection. And if I just open up, say, injection.dia and injection.json, because we had sort of more than one model, it forced us to think of what is dia specific and what is JSON specific and what's actually common. And that was actually really, really important, because that meant that a lot of the processing logic that originally was in our dia front end, in our injector, ended up moving to a common injector, and then it meant that the codec specific formats, models, were a lot simpler, both for JSON and for dia. And so it was very useful whilst you're developing the product to have this notion of multiple injectors. However, in terms of usage, in terms of actually how does the product get used, the conclusion that we've had is that, at least for now, there isn't huge amounts of need to support more than one injector. The reason why is because we are the main users of Dogen, and we only use it in one way. Whatever the canonical injector is, that's how we use it. Other people in the future may come and may want to use it differently, but that's just not what's happening right now. So we are now paying the cost on everything we do of having to worry about JSON and having to worry about all these different formats, but in reality there's only one format that's actually actively giving us value. So because of that, it makes more sense at some point to start deprecating multiple injectors. Not immediately, but over time what we'll end up doing is, especially when we move to text, we're going to start deprecating both the JSON and the dia formats. I mean, I may leave it in the code base, but I'm not really sure if we're going to keep, having to convert models and generate and so on. And then eventually, if they do find active use, then we can reactivate them. But it makes no sense to pay the costs as we develop. So this is something we have to look at. Right, so we can do our final commit now that everything is green. I'm just going to make a commit here. I mean, there's no need to do this commit, but right, as you can see, you have a whole lot of temp commits. Like I said, this should not be temp commits. This should really be real commits that get pushed into a feature branch. But at the end of this, we should just squash all of them. Now you notice that I'm very lazy, and I normally just I just come here and then I just uncommit everything, and then just commit the whole lot. It's probably not how we should do this, really. You should probably do it properly and squash and so on, but I'm lazy. So what we'll do is we will create 2 commits out of this many files that we changed. I like committing my agile related stuff separately because well, it doesn't break anything, right? So you should try to make your commits as focused as possible. So what we'll call this commit is probably something like well, something like we've already done for every other model, I guess. So replace names and related types in logical model. And then we go to our sprint backlog and we close our time. And so there we are. It took us roughly half of a sprint to do this change. I mean, I'm going to leave this task open because what we now need to do, she's not very pleasant either, but in fact, before I forget, let's just put that story here of replace meta model IDs with stereotypes. We probably already have a story for this. Check backlog, just so we don't forget. What we now need to do is we now need to go through the files and just double check what we've done. It's basically a mop-up. Again, it's not going to be a pleasant exercise. I'm not going to bother putting down the videos because it's nothing particularly useful. Let's just I'll just show you as an example. What we need to do is we did a lot of changes, and some of these was search and replace and so on. So what we need to do is we need to go through. Let's just even say identification. I mean, probably don't need identification, but let's just say identification. And all the non-generated code in identification, such as, well, actually, I don't think we have any non-generated code in, but helper, say, for example. Just a quick scan through all the files and make sure that we didn't do anything particularly silly. So this file looks perfectly fine. Oh, actually, the other thing we wanted to do, also before I forget, is that factory of ours for the meta naming transfer, meaning the builder. Yes, this guy here was the logging of this was very bad, wasn't it? So what we probably want to do is we want to check. We want to check the names coming in. See if I'm in the right place. So if you remember, there was an index here, and we were logging some stuff, like for example whether the names were valid or not. But we didn't have much information as to what we're processing, which is not ideal, really. So every time you call add, you should probably tell me what are you adding. So you're adding an index of logical meta names, and there's a pair. So presumably what you should probably be doing here is something like processing and then something like pair dot first, presumably, and I think I might even go as far as saying pair dot first dot value. Oh no, actually I'll leave it as pair dot first. Now there's been sort of an ongoing discussion, really. I haven't quite figured out what's the right way to output the primitive. So what we'll do is, so these are logical meta IDs, right? So if I just say something like entities logical meta ID IO. Right, so let's just build code generator with this. Let's also enable logging again. It'd be really nice to just have an environment variable or something to enable logging, wouldn't it, really? I seem to always have to do this faffing around. See if we can find the generation somewhere. Dogen.dia. Go up to the model. What is the log file? Well, as you can see here, this is the logging that wasn't particularly useful 5 seconds ago. Now, as you can see here, we're outputting a primitive, and the way we output the primitive is by, because it's a type, not the primitive type, but a real type. Well, not a built-in type, let's be precise. We decided that the outputting of a primitive should be with all this singing and dancing, telling us the type of the primitive and so on. However, the problem with that is that in some cases you just want the value of the primitive, really, and they end up doing dot value all over the place. So it's not very clear how you should output a primitive, whether you should just not bother with this and just output as if it was a string, just like you would with a string, or not. Still, I keep going backwards and forwards on this. I haven't quite decided what's the right thing to do, really. But for now, that's what's happening. So when you dump it to the log, it's a bit verbose. But at least now we have some kind of idea what it is that you're processing. And it's telling you the physical names. I mean, I could dump the list of physical names here. And then the second bug that we need to fix is the fact that the physical names on the artifact set seem to not have the right logical meta name. Best thing is to try to understand where the meta index name builder is being called from, because let's go back to RG, because clearly it's receiving a partially formed thing. Right, so this is the chap. Let's have a quick look at what this chap's doing. So, right, see here we are obtaining the I think around here somewhere we'll be creating an artifact set so this map here already contains archetype name sets. Let's just have a very careful look at this method. We have a physical meta name, logical meta ID. We obtain types for that. Start building physical meta IDs. So the artifact set or archetype name set already seems to be pretty generated here. We are just updating physical meta names, really. I think we need to go one level up from here. Let's try to understand where this transform is being used. So there's going to be a chain somewhere. Here we are. And in this chain we're going to be building the meta model. And that's probably the guy we want. I suspect around here somewhere. Okay, so this is the problem, I think. The problem is the backends themselves. Right, so now this is a sort of the interface between generated code and non-generated code. The backends themselves are generating the model. So when I say that Dogen generates itself, I mean this quite literally, really. So if you were to have a look at say text.cpp, what you're going to find is that inside of a backend, so we're now inside of the C++ backend, still a bit messy, but I get the gist of it. So if I take something like the types facets, in here you have a set of generated codes that tells Dogen about Dogen. So you can see here we are adding the meta model, physical meta model representation into Dogen, and this guy here will be creating the archetype, and then presumably the facet, so there will be an equivalent thing here for the facet, which will then generate the, here we are, the facet is being generated here. And then the backend will be generated somewhere here with a very strange name of transforms, purely because of where we are at the moment in terms of code. That generates a backend. So up to now there are no artifact sets, as you can see here. And then if we go back to where we were, this guy here is now obtaining all the backends. Okay, so that's fine. So up to now we've generated 1/2 of the meta model. So let's just try to see if we can figure out where we were. This is pure use white line here, blank line. So here we just basically meta model assembly, just assemble the meta model. Nothing particularly special happened. Then we need to compute the name indices. Now I would have thought that when we compute the name indices, we would start creating artifact sets, but it didn't seem like it. So let's have a quick look at the shape of the meta model again. I think we missed something here. So the meta model is composed by backends, which is fine. It's composed by index names. What are these index names? Index names. So you can see that we don't really seem to have any artifact sets just yet. So archetype sets is what we're looking for. We have archetypes. Okay. Somewhere around here we should find these archetype sets, and that's what's confusing me slightly at the moment. Can't find them. Let's first locate them in the model. Might be the best way to do this. Again, you can now see why I really profoundly dislike the UI, because of course searching is quite linear. It's worse than linear, I think. You're just eyeballing things. This will be a control S, control whatever you bindings are in Emacs. 5-second job, 1-second job even. It's a multi-minute job using a UI. But there you are. It is what it is. So there's an archetype name set somewhere around here, which is kind of the meta representation of the archetype set. So if we just go back and explain what we're looking for. So you should see an archetype set somewhere around here. See these artifact sets. The artifact sets are those regions in logical physical space that belong to a point of the logical model, so that's all fine. There's the artifact set, so that's the instance version of it. Of course, there'll be an equivalent thing for the meta, which is the archetype. So there should be an archetype set somewhere. Of course, you have to remember we haven't seen this code for a while, so it's possible there's some refactoring that's either taken place or that not yet taken place. You might be looking for something that doesn't yet exist, or does no longer exist. So let's just try to locate ourselves again. The problem we had was we seem to, when we looked at the indexes, sometimes you just have to go back to the beginning. We looked at the indices, and particularly in the archetype names by logical backhand name, the meta name, so the archetype name set, this is the key. The archetype name set, which should be related to the index, and the index is, it's rather difficult to spot things. Also a bit frustrating, I think. It's probably one of the reasons why I need to really move away from this UI. So index names. Ah, yes, now I know why we're getting confused. It's because it's on the physical, on the identification, that's why. Here we are. Now then, this guy here contains a logical meta ID. So presumably, the meta in the name index builder, this is the wrong way around. The meta name index builder must build these indices, and they contain the set. So, okay, all of this to say what? In the meta name index builder, we must have forgotten populate the meta biological meta name. So it seems to me, let's just look carefully again at, right, you see this is the guy here. We go and start populating it. It's all kind of making a bit more sense now. And around here, somebody must create the artifact set, artifact new set. Bingo. Physical metanames, biological metaname. Right, this is where it gets created. And then this actually does not look too bad. Logical meta ID seems to be populated. Oh. So you can see here that the logical meta ID is being populated. However, when I look at the log file and ask for the logical meta ID, it seems to be blank. Now notice, quite interestingly, notice that yes, okay, so this is basically a pair, which is what the map has, and then we're saying there is no logical meta ID, but the metanames are correctly populated. Now let's just have a very, very careful look at this, because it actually looks alright. Now we know for sure that the logical meta ID is being populated correctly here. Makes no sense. So let's just see if this is some weird coincidence that we somehow found one where it's not being populated, but in general they are being populated. So if I just do a quick search for logical meta ID, in general they are blank. No, I think that's very puzzling. Because as you can see, the logical meta ID here is populated. And as far as I can see, the logical meta ID is exactly the same. That is extremely puzzling. So let's just say populating meta logical meta element. So here what we'll do is we will just make sure we know what it is that this thing thinks is populating. We'll just also make sure that we have got IO for that, which we do. Now let's just build a new code generator, and then let's just repeat the exercise. Oh, that's the one we want. And then let's look at the log file. That was a bit quick. It is a small model, to be fair. Right, so now, to be fair, we're not really interested in this because we know nothing has changed in there, but we really would like to see where we should be in the compute and indices transform. Right, so now then, if we look at this, right, as you can see, that actually looks quite healthy. They all seem to be populated. None of them are blank. So the only other thing is, could it just be that we're overwriting this with something else somewhere down, further down the line? I mean, it's obvious here that it's blank, and this is being done at the meta index builder level. It looks alright from the perspective of the transform that populated originally. I don't know why you call this variable G, to be honest. Populate metanames, physical metanames by logical metaname. Let's just make sure no one else is touching the logical meta ID. No one is, not here anyway. So it seems it should have been populated, so that looks good. And then the question is anyone touching it here? No. This is very puzzling actually. Missing something very obvious. Let's just reflect for a second. It's definitely the right name of the method. Logical meta ID. Value is blank. Meta names are being pushed back. This is a better variable name. Just say instead of G. I mean, one thing I always. In fact, let me just take opportunity to do this because LSP mode was not brilliant in the past. I didn't used to rely on it so much as I do now, so I keep forgetting that there's a nice rename that does the right job. Right, now then, without a doubt we're populating the variable here. But however, we don't seem to see that value populated a bit further down the line. So perhaps what we should do is just keep logging. I mean, this is a little bit strange, but let's keep logging. So if I then take one of these guys here, as I'm adding, look what's happening here. We're adding one thing at a time. Why don't we add the whole thing in one go? Right, there's some logic going on here. Okay, fine. This is actually simpler than I thought. All we need to do is to make sure that we create. So we must be creating some kind of output. This is copying across stuff and we're just missing some stuff. Well, as you can see in the commentary, there must be all sorts of reasons why we did this the way we did. What we'll do instead is, instead of wasting a lot of time here, is we'll say the destination logical meta name is equal to the source. Where is the source? There it is. Source dot logical meta ID, and that will fix our current problem. And just to make sure we're not doing anything else silly, let's just have a look at other properties. Archetype for label. I'm sure we're not populating archetype for label. So, of course, you might ask, why are we doing this at present? I'm not entirely sure. There will be a logic at the time. Now I can't remember. And like I say, you have to choose your battles. You can't, for every single problem you have, you can't look in detail at every single issue. Sometimes you just have to fix the issue and move on, because otherwise you're never going to get anywhere. So what we'll do is we will regenerate the model, ensure the fix is good, and move on with our lives. And you can see here that the logical meta ID is now being populated with the right meta ID, which to me means we've done our job. And since we've done our job, it's time to commit. And that is the end of this exercise. We don't want logging. That's just cosmetics. That's just the line. So let's just say something like Refactor in this. Let's try to see. I don't. You may think I'm a bit OCD, but I don't really like this commit where we start committing lots of stuff, unrelated stuff together. So this guy here is doing something useful. What we mean is identification, populate missing properties in index, method name index. And then these guys here are more cosmetic changes. So we can say physical cosmetic improvements to name in this building code. So to code building name indices. Right, and then we could also say whatever that is, models, cosmetic changes to the identification, whatever that was. And there we are. Okay, so just for good measure, let's make sure that we haven't broken anything. You should always run your test before you push. No one likes a red build. That looks good. And go back to Git. And oops, we need to merge to master as usual. Push. And it's pushed to all our backup Git repos. And there you are. So with this change, we kind of more or less done the bulk of the work for the identification model. It was hard, but more or less what you'd expect, I guess. Now we just need to do the mop-up exercise, which we'll just do on the side. I don't think it's interesting enough to record a video, so I'm not going to bother. And that's about it for this series of videos. Thanks very much for watching.